After learning the material in this video, you will be able to understand the laws of basic algebra and how to manipulate equations. You will be reminded about the rules for working with powers and radicals. You will be able to simplify or factorize algebraic expressions and feel comfortable simplifying fractions. All algebra is based on a few simple rules. Let's start with the simplest one, which is called commutativity. This rule says that some expression A plus some other expression B equals B plus A, which means that you can change the order of the addition. Similarly, you can change the order of the multiplication, and then A multiplied by B equals B multiplied by A for any A or B. The next law is law of associativity. It states that A plus B plus C combined equals A plus B combined plus C, which means that you can change the order of addition with any expressions you want. Similarly, multiplication says A multiplied by multiplication of B and C equals multiplication of AB multiplied by C. The last law is called distributivity. It says that A plus B multiplied by C equals AC plus BC, or A minus B multiplied by C equals AC minus BC. You need to know that all of the rules of algebra are a result of those three laws, and everything is extracted from them. Another important thing is related to manipulation on equations. If you have any equation, both sides of this equation could be added, subtracted, multiplied, or divided by the same expression, while preserving the same equality. The only exclusion from that rule is division by zero, which is prohibited. Let's try a simple example. We have an equation x squared plus x plus 3 equals 7x minus 5. And for example, we want to subtract 7x minus 5 from both sides of that equation, preserving the equation true. So what we will get on the left side is x squared plus x plus 3 minus 7x plus 5. And on the right side, we will have 7x minus 5 minus 7x minus 5. So pay attention that on the right side, everything cancels out and leaves us with 0. And on the left side, you have x squared minus 6x plus 8, and then it equals to 0. Also, we can try to divide by 7 both sides, or to multiply by 1/7. And then what we will get is 1/7 x squared plus x over 7 plus 3/7 equals x minus 5/7. Let's try something else. We can divide both sides by x. So if you take x squared plus x plus 3 equals 7x minus 5 and divide both sides by x, we get on the left side x plus 1 plus 3 over x equals 7 minus 5 over x. Pay attention that this will be true only for x which is not equal to 0, because you cannot divide by 0. I want to remind you that a to the power of n is just a multiplied n times by itself. A is called basis and n is called power. Now please don't forget to write all of those rules down for your future reference. For simplicity, we can divide those rules into two groups. First, having the same basis and different powers, and second, having different bases but the same power. Note also that a to the rational power of m over n is just nth root of a to the m's power. In this course, we will be mainly interested in exponents such as e to the power of j theta, where theta is some given angle, and we will be manipulating that kind of exponents a lot. Also, you need to note a few important things. You want to avoid following common mistakes the students are doing. First one is using a to the power of n, a to the power of m, and writing that as a to the power of nm, which is of course incorrect. You need to use that rule instead. Second mistake, which is very common, is writing something like that. a to the power of n plus a to the power of m equals a to the power of n plus m, which is of course also incorrect. This is also not true that this one equals to a to the power of nm. This is also incorrect. Another mistake, this is a to the power of n, b to the power of m equals ab to the power of m plus n, which is again incorrect. So you should remember not to make all of those mistakes. Similar terms could be combined together using the distributive law. Let's take a simple example. Given x not equal to 0, we want to factorize the following expression: x squared y plus yz squared plus xyz. Now, we can factorize it in multiple different ways. Obviously, you have same y here, there, and there, so you can take it out. So you can say that this is y multiplied by x squared plus z squared plus xz. But you can also factorize it by multiple other ways. For example, you can say that since x is not equal to 0, you can always divide by x. And then you can take x out of the brackets here. So you will have xy. So x will be divided here by x. There we need to divide by x. And here we need to divide by x. So it will be x squared divided by x, which is x, plus z squared divided by x, and plus z. Also, you can pay attention that here you have z squared, and here you have z, so we can take and put out z, and then this is what we will get. So this is still xy multiplied by x plus z in common, and then you have z over x plus 1. So this is one of the possible factorizations that we have here. The following formulas are very useful for factorization. You can write them down for your future reference. Recent survey showed that about 70% of graduate students don't know or don't remember how to work with fractions. I want you to pay extra attention to this section, because if you don't have perfect control over the simplest topic, everything else in this course will look like a horrible nightmare. There are only two basic rules you need to remember to work with fractions. One rule, how to multiply fractions, and another rule, how to add fractions. So the first rule is the rule of multiplication, which says that a over b multiplied by c over d equals ac over bd. A, B, C, and D could be any expressions you want. The conclusion from that is very simple. Basically, if C equals to D, then you multiply it by 1, and then it's not changing the fraction at all. So you could multiply or divide numerator and denominator by the same non-zero expression without changing the fraction. This expression could be anything, any combination of letters, numbers, and so on. The second rule is the rule of common denominator. So this rule says that a over b plus or minus c over d equals ad plus or minus bc divided by bd. This is common denominator rule, and the explanation for that is very simple. You could multiply the left part, which is a over b, by d divided by d, which is 1, without changing anything, plus or minus c divided by d multiplied by b over b, which is also 1 and not changing anything. So then you will have common denominator, which is b multiplied by d, and then the numerators will add together and provide that rule that you have as number 2. Please never use any other rules, which are not direct conclusion from the rules above, because most probably they are wrong. Misconceptions are very difficult to correct, and somehow many students have tons of rules they think they remember about fractions, and most of them are wrong. I want to warn you about one tricky thing with fractions. Let's say you have the following fraction: a over b divided by c, and another fraction which is a divided by b over c. Naturally, those two fractions are not equal. Why? Because this fraction is a divided by b over c. It's like a multiplied by c and divided by b. And this fraction is basically a over b, and then we need to divide by c. So it's a divided by bc, and those are completely different things. Now, let's see why this one is true. Because I can basically multiply here by c and here by c, and this c will cancel with this c. So I will leave here with ac, and at the bottom part it will be b multiplied by 1, which is just b. Let's try another example. Let's say I want to simplify the following fraction. Naturally, I cannot cancel a divided by b and here a divided by b, because this will be wrong. I have to use only the rules that we learned. So, what can I do here? First of all, I want to get rid of those two things. So I need to multiply numerator and denominator by b and c. So let's see what happens. So it's a over b divided by a over b plus a over c. I will multiply that one by b and also that one by b. And this is what I will get. B and b will be cancelled here, so only a here. And then a over b multiplied by b is a, plus a over c multiplied by b is ab divided by c. Now I need to multiply numerator and denominator by c to get rid of that c. So this is what I will get. AC as numerator, AC plus AB, because this c will cancel with this c. Now I can simplify it even more by dividing by a. Numerator and denominator. By the same thing, I have to use the same variable. So this is what I will get from that. It will be c plus b. And this could be the final answer. But if I want, for example, some other representation, I could divide also by c both numerator and denominator. And then I will get 1 over 1 plus b over c. So this is also correct answer.